Power series, part 2. Essential question: what is a power series? Can you identify the interval of convergence for a power series? Can you identify the function of x represented by the geometric series? Let's start at the page that we left off. And here is, we're going to be talking about functions represented by series. Let's take a look at this first series. It's a geometric series where the radius is equal to x. And let's graph them one at a time, these partial sums. Y sub 1 is equal to 1, and you can see I've graphed it right here with a green line. Y sub 2 is also linear, 1 plus x, and I've graphed it with a red line. Y sub 3 is a quadratic, which is this pink right here. Y sub 4 is this cubic, which is this blue right here. And then Y sub 5 is this quartic, which is this black right here. Now, what's happening is this is getting closer and closer to looking more and more like this portion of the curve 1 over x. Okay, remember this is the sum formula. Remember, in a geometric series, the first term right here is 1, and the ratio is x. So the sum of the infinite series is going to be equal to a sub 1 all over 1 minus r. And in this case, it's 1 over 1 minus x. And this is a function. And this function is being represented by this series. This is going to be a replacement for what we've been looking at as far as functions. We're going to replace these functions with a series. But it looks like the series really isn't covering the whole 1 over 1 minus x. It's really only going to look like it covers from -1 to 1. And that makes sense because remember, in the geometric series, the only way there's convergence is if the absolute value of x is less than 1. Okay, so let's look at a definition of a power series. So a power series is different from a series of constants in that a power series has an x in it, where a series of constants was just constant terms being added together. Now, that first power series is centered at 0, and the second power series that says x minus a to the second, and so on, is centered at x equal to a. Now, let's take a look again at this geometric series that we've looked at before. And again, let me remind you that the first term is 1 and the ratio is x. And we know that this will be equal to the function 1 over 1 minus x, but not for the whole domain, not for all values of x, only for values of x that are between -1 and 1. Okay, given that 1 over 1 minus x is a representation for this geometric series, can we find a power series that represents 1 over 1 plus x? If we rewrite this in this terms, 1 over 1 minus opposite of x, it's in this geometric format. And we can go ahead and remember this represents our r. This represents our r. And so our first term is right here, which is 1, and we're going to take this r and we'll take it to the first power, the second, and third. You can even think about this being to the 0 power. That's why we get the 1 here. So this is the representation for this function as a power series, and if you want to simplify it, it'll look something like this. But again, you have to remember that you can't just put any old x to represent it. It must be only x's, absolute value of x has to be less than 1. So this equality only holds if this is true about what x is. Let's find a power series that represents x over 1 plus x. Or so there's a slight change from the a part in that now there's an x in the numerator. So how would we go about finding a representation for that? So we have x over 1 plus x, which is x times 1 over 1 plus x. Remember, we just finished finding a representation for this. So I'm going to put it right down here, which is this. And then I'm going to distribute the x all the way through, and this is now the representation. This will represent this function right here as long as the absolute value of x is less than 1. And this requirement for x is what we call the interval of convergence. In other words, it only matches when the graph matches this as long as x meets that stipulation. Okay, your turn. You see me do a couple of examples. Why don't you stop the screencast and see if you can find a representation for this. And here's the answer. 1 over 1 minus 2x. It's in that geometric format. A is 1. The ratio is 2x. And we can go ahead and just take that r into the 0 power, to the first, to the second, to the third, and so on. We can really write it like this. Now the stipulation is that this radius has to be less than 1, and if you solve your inequality, then this is what x needs to be. So you can either write it that way or you can write it this way. And that's called the interval of convergence. Okay, now try another one. This time we're trying to find a power series that represents 1 over x. And I'm going to give you a hint as how to write it. And here's the answer. I'm going to, they've given me a hint on how to write it this way. And then I'm going to rewrite it this way with a minus, and I'm going to change this. Now these two are exactly the same, but then this has that geometric format where I know what the ratio is, and I know my first term, and so I just take my ratio to the 0 power 1, 2, and so on. I'm going to do a little algebra here, 1, and I'm going to factor out a negative 1 here, factor out a negative 1 for both of those, and so on. And I end up getting this power series, or I can write it like this. Now, the big change is this is centered at 1, not centered at 0, because this says x minus 1. And that's the power series that represents that function. Okay, now let's have you try this one. Find the interval of convergence and the function f of x for this power series. And here's the answer. So our ratio is 2x, and to converge the geometric series ratio, the absolute value has to be less than 1. So I then find my interval of convergence to be between -1/2 and 1/2. Now, since it's a geometric series, I know the first term, I know the ratio, I can use the formula to represent the function, and f of x is equal to 1 over 1 minus 2x.